So 7 layers of OSI model, open system, interconnect. So when you are communicating in the network, or you want to troubleshoot a network, or maybe you are maintaining the network, you have to keep all these functionalities of the 7 layers. So any issues occur, or maybe you want to implement a network, or maybe you are installed a server with some type of web server. Okay, so this is more helpful to understand how it is communicated. Again, guys, OSI layer never be used by any organization in direct implementation. It is just for understanding purpose. It's a reference model. We don't use OSI, but we should know and understand work of OSI. So each layer comes from, first one is application layer. So application layer is an application level in the net communication. What is application? Your web browser is an application. So web browser is a client application. Client side application means where you can able to access a website. Web browser use it to access a website. Which protocol we use in this one is HTTP or HTTPS. So it is application layer is dealing with the application. Application dealing with the applications and protocols. Okay. Application can be client side or can be server side. The client side, web browser is an example for a application. Outlook, we have seen that Outlook for mail client it is. Outlook is a mail client application. Okay. Putty is used for a remote access, like using protocol SSH and Telnet. You want to see Putty? Putty is also an application. So I want to connect my remote server using SSH or Telnet protocols, so I can able to use this Putty. Already I showed this mobile extreme. This is also an application to connect with the different protocols to the different type of servers. Okay. FileZilla is an application to upload or download files to the server using FTP protocol. MSTCS, MSTSC. So type MSTSC, it is showing remote desktop connection. Okay. So what is the purpose of this one? This is an application to connect remote system and access their desktop environment. Like this. So client side, we have an applications and server side also application. So you're accessing a website means there is a web server. So using Tomcat is a web server application, HTTPD, IIS, these are different web server applications are there. Mail server, Microsoft Exchange mail server, Microsoft Exchange application, Zimbra application are work like a mail server applications. Telnet server, SSH server, kind of stuff are there at a server side. Means there is a client, there is a server. So you are trying to communicate from one device to another device, or maybe one client to another server. So we need protocols to understand what type of communication, and we need an application to communicate with what type of communication you need it. So application layer dealing with the application part in the communication, like an example, web browser, Outlook kind of stuff. At least understand this line side applications. Server side may not have an idea completely, you know it. Don't know, but you know client side applications. Already you have seen these things. Okay, so that is application layer. I told protocols and port numbers before we start this 7 layers of kind of stuff, because these protocols and port numbers comes in the application layer. protocols and port numbers comes under application layer. So I do not want to confuse that application part. So separately I code because it is also important. Next one is presentation layer. So what is a presentation layer? So in a presentation layer is used to encode and decoding the data. Means your data is in different format. Now it is a web browser with some document format, right? I want to upload a file or download a file. I want to access remote connection. Okay, right? I will share anything like a data, sending a messages. So we send different type of messages, different type of data with different type of things we will access. See, it contains a text and also some search bar, some other program HTML links are there. Direct text messages are there, pictures are there under this one. Okay, different colors patterns are there, different pictures are there. So all these things, for example, if I open, try to open something here. Can you see there is a picture, there is a text, there is a links. Okay, so all these things is a data only. Whatever the type of data it is, it convert the data into standard ASCII format, American Standard Code for Information Interchange. That is ASCII format. Whatever the data it is, it can be a text, HTML, JPG, MP3, GIF, PDF. So whatever it is, the data it is, so it will be converted into ASCII format. And that ASCII format further convert into binary format, of course. Okay, low level format. So what is the presentation layer? First point is encoding and decoding. Encoding means it converts your data into ASCII format and further BSD format, means binary coded decimal format. Next, compression and decompression data. Data is always huge, right? So you have a huge amount of data. It will try to compress the data and send. Next one is encryption, decryption. Already I told HTTP, HTTPS. HTTPS, encryption. HTTP, no encryption. So data, while it is sending, it encrypts the data. If you are using HTTPS, SSH protocols, it try to encrypt the data to transmit the data. So encryption always protect the data from others, attackers. Guys, understand application and presentation?
Yes, sir.
Yes. Next one is session layer. What is this session layer? Session layer is with a simple line, create a session, maintain the session, terminate the session. It means it contains so many things. Actually, it is a very important in a communication because you are sending a request, right? This is where it is origin. This is sender. You are sending. So when you are sending, a session will be created. This is a particular, this is you are sending a request. This particular session will be created. And it contains a session ID also. Session ID. And this session, what it will do. So for your request, what are the requirements? A collection of information is there. What are the requirements? What are the protocols? What is an application? All the requirements for your sending. So that will be connected, that will be managed, that is will be connected here only. Okay, so that will be tracked from here only. That is your session layer will do. Okay, so once it is reaches here, you send a request, it reaches, and this system verifies your session ID. Check your session ID and what kind of session, what is the requirement, all the information you are sending, it will be gathered at this place. Your data is cut into multiple pieces while it is sending, but it will be gathered under one single session only. Okay. So for example, you order a dress. Okay. So you order a dress like a top, second one is bottom, Okay, and also you order some coat. Okay, separate pieces, not as a single set. You are getting under set, but all are having a one ID only. So these are all belongs to a particular dress. So what it will do? So this particular dress, again, it can easily assemble here and understand what you are selling. This is one way, but again, I'm trying to say, just for our understanding only, here it is session ID. When you are try to send a request with your protocol and port numbers and all, okay, and the session ID will be created and the session will be session ID will be understand by here. And it is has to be given a reply with the same session ID. In the same session, again, it will attach what is your requirement. For example, in a web page, here it is. I open this link. So I send a request, give me this information in this particular page. It understands the session and it will give this data with that same session on. Okay. So it is little thing. I will tell some example also. This session is how serious this session will do it. Guys, simple understand. You know, nowadays everything is UPI payment, right? UPI. I will tell in UPI matter because you have seen that one multiple times. Okay. You scan the code. Oh, no, don't go to UPI. It is a payment only, but still it's a different thing. Yeah, I will tell a story. That's my personal experience. It is. So you will get some information from it. You know, one day I want to go to travel, so I have to book a ticket. The ticket timing is it's 10 o'clock. You have to book a Tatkal ticket. Okay, so it's at 10 o'clock. You have to book a Tatkal ticket. We have internet, very good Wi-Fi, good high-speed internet is there. We have a high-speed internet speed is there. So 10 o'clock, it will be, if you within a minute, I can able to book that. Okay. So I send a request to IRCTC website. I send a request to the IRCTC website. Okay. So I'm doing this like I log in first of all. Login. Then what I'm in from my mobile phone. I'm doing in my mobile, not laptop. So let's remember. Okay. I log into my IRCTC website application, and then I check the ticket. I'm doing everything one by one. Finally, payment. Okay. When I'm trying to do payment, power cut happen. Okay. You're connected to Wi-Fi. That Wi-Fi is now down because power cut, Wi-Fi is down. So what will happen? Anybody? You're connected to Wi-Fi and you went outside, like in your home, Wi-Fi network is there. You're using it. Now you went outside. Your Wi-Fi is not there. So what will happen? Or power cut, your Wi-Fi is switch off. What will happen? Any?
We won't be able to access the internet.
Okay, then if it is a mobile.
Then we can use our mobile data to access the internet.
Very good. Very good. Okay, your Wi-Fi is off automatically. It is connected immediately to the mobile data. So we can access with the mobile data, right? So here it is. I'm doing a payment. That time my Wi-Fi is down. So mobile data automatically came. And this payment is interrupted. Of course, immediately within a second only, I got 4G connection and I can continue. That should be continue, but it is not continue. It is interrupted. Okay, payment failed. Payment I have already done, but I didn't get anything. Payment is done, but the final stage is not done. Okay, so when it is returning the transaction details to me, that is failed. Okay, so what happened? Again, I have to log out from the application. Again, I have to log in and with the mobile data. Then I try to book the ticket. Of course, the time's up. I can't able to book the ticket. I done at 11 o'clock. Okay, so simple. First time I log in with the Wi-Fi network, means some other network. Next time log in. So even I should log out and log in. Then only I can able to connect. What is happened here? It is for security, they lock with a session. Okay, your network, what the channel of network it is. Okay, and your application, your mobile, your login details is everything they put it in a session. If the same session, so they can able to reply. I done a payment, I can able to get the transaction details, the booking information, I will get it. Now session is interrupted with a different network. Session is gone. I cannot get anything from outside to inside. It's a little long story, but thing is, importance of session layer is, so when you're sending a request or when you giving a reply, okay, from here to here and as well as here to here, data will be transmitted, transactions will be happens, okay. So data is transmitted or any transactions are happen in and out, request and responses will happens in a single session only. The session is interrupted, so again you have to re-establish the session. Okay, sometimes it is possible with a certain application to maintain the session. Sometimes it is difficult. Simple example, I'm downloading some data from internet. Nowadays, we are getting high-speed data transmissions. Okay, earlier it is very low. For example, I am downloading 100 MB file. I'm downloading 100 MB file. 90 MB is already downloaded. So I'm waiting for 10 MB waiting. And 99 MB is already downloaded. Only 1 MB is left over. Internet is down. So you cannot download remaining part. If it is a less than 15-second interruption, no problem. So maximum 15-second interruption is allowed. If more than 15 seconds, the session will be closed. You cannot download anything. Again, you have to start downloading from zero. Why? Because this session will be automatically closed. But use certain application like a free download manager, internet download manager, they'll maintain the session. They'll save the previous session ID and then they'll reconnect with the session ID and they will also balance from what is the downloaded part, what is the remaining download, entire details will be in the session. It is saved. Okay. So that's why we can able to download even multiple interruptions. You can able to download with the torrents, internet download manager, free download manager kind of stuff. Okay. With the browser, any interruption is occur, that's it. You cannot download further. Again, guys, simple. We should go. We should not go with more time on it. Okay. What is a session layer? I put only single line, but there is a lot of explanation is there. It will create a session. So when you are sending a data, so automatically when you are sending, so automatically a session will be created. And the session will be maintained till the complete transaction, means you send and you received. Okay, the total transaction completed till that time session will be like that only. Okay, termination session means once data is transmitted, then automatically session will be terminated. So for example, I open a site, so automatically I send a request, the session will be created and sent to the remote server. So that server, and I received a data. Now session is completed. Okay, session is completed. Now still session is going on. Why? Because see, It's a cross mark, means still loading background. So many things are loading. It is showing like that. Once transaction is done, session will be terminated. Even you can observe here, this will session maintains our Gmail accounts, these Google Docs, the websites, what they will do. Our browser keep update, means it create, you can recreate the sessions, again session, and completed terminate every 30 seconds or 15 seconds, 25 seconds. Okay, depends upon the website and it depends upon the web browsers. The session will always click again and again. Mainly like a streaming kind of stuff. It is there. Okay, simple to understand the session, guys. You open, you send, you connecting remote machine. Session will be created and maintain the session till the transaction is completed. Till the you disconnect the session or transaction is completed. So session will be maintained. In the session, the requirements, what is your requirement? What is the data attachments, everything will comes under thing. So I send a simple this request. What are the data it is, all attachments, everything will be their locations. These are in a different locations. Okay, the everything will be connected to your session only. Okay, just maybe it is good. Okay, guys, understand somewhat at least session layer.
Yes, sir.
So session layer, when you are trying to connect and establish a session automatically. First, it will establish a session along with your data and information, everything. Okay, and session will be maintained till your complete the transaction. Means entire transaction is completed, the session will be over. Sometimes this session also having a time limit. Some are having a 180 minutes, 180 not minutes, 180 seconds. Some are having a 90 seconds. Okay, so 180 seconds or 600 seconds. For example, you open a website called ICICI Bank, for example, like banking websites. You open a banking website at 10 o'clock. And you do some transaction, you check some details and you do some transactions. You done, you have to log out, right? So once you are done, you have to log out. So, some people, lazy people like me, they leave like that only. I want to check a mail. So in the morning, I open my mail and I leave like that only. Okay. So I didn't close it. Once I check the mail, I have to close it like this. But I didn't close it. So what happened? That is a mail account. It is again and again session will be repeated. But bank is very sensitive data, right? You keep it like that. Someone sees your data, maybe they will transfer some data. Someone steal your data that much time it is there, even it is encrypted. If you are giving more time for other people to attack you, right? So what bank web servers, what they will do it, they will put a session limit. Okay, 60 seconds, 30 seconds, or maybe 180 seconds, 600 seconds. So they put a time limit for a session. So within that time limit, you have to complete your transaction. If you are not done, it automatically, if you are not log out within that time, it automatically log out you. You try to do something after 600 seconds, automatically say log in again. Okay. Even IRCTC also will do like that. You open and within 5 minutes, you complete your process. Good. You extended, you have to log out. Automatically to log out your session. Okay, that is a powerful thing about a session. Not only that, so many explanations there. Okay. Next, very important is this transport layer, guys. Transport layer, very big one. Okay, so I will try to put more. Try to put simple map. Okay. Provide end-to-end connectivity. transport layer provide end-to-end connectivity. What is end-to-end connectivity? From what are the you're sending to receiving end. You're sending to receive, receive to sending again. Means A to B, B to A communication. Okay. So total entire communication actually maintained a transport layer. Means the data protocols, port number kind of stuff, data management here, controlling of data transactions. Okay, everything will be under transport layer. It's provide end-to-end connectivity. What is this transport layer will do it? So what are the data you're transmitting? The data will be segmented. Means, for example, I'm sending a message just for our understanding, guys. It's not actual one, just for our understanding. I send a message like a hello, how are you? So this is the message I am trying to send, for example. So this is total data, just for our understanding. The originally data means not just a text message. It has so many things included, including your session details are there, encryption details are there. Okay, so your data is actually encoded data. It is compressed format. Okay, so it's not just text message. It's not just text message. Many things: IP address, protocols, port numbers, and encryption, decryption, sorry, encryption, encoding, compressed, okay, session IDs, session information is there in the data. Just for our understanding, I'm giving this. The data will be chopped into small parts. Actually, it is in a binary format, just for our understanding, every time like this. What this transport layer divide the data into small chunks. Okay, small chunks. So they will put this small chunks. Okay, so and they will put a numbering on it. Just for our understanding, they put each one as a number. Okay, numbering and sequencing. Just for our understanding and remembering purpose only, I tell this example. Very simple to understand. It segment the data. Segment the data means chop the data into small pieces. Numbering and sequencing. Numbering and sequencing, what is it? It will place an order of this segmented data. This segmented data. So what is the use of this one? Guys, huge big size data cannot be transmitted. If any error is there, problem is occur. For example, I send a hello, how are you message. For example, I'm sending same message in a one shot. While you're transmitting data, data is corrupted. Transmitting data at end, data somewhere it is corrupted. Again, you have to send. Again, you have to send until unless the receiving side confirms received a corrected data. So once you send error, second time share somewhere error. So finally, the receiver received a data and it confirms the received corrected data. Okay, so this is what happened. You send a data, receiving side will verify the data. If any issues are there, it drop the packet. Okay, so this is more difficult to transmit huge size of data, but chopped data means small size of data can be easily transmitted. For example, first packet sent and the other side it is received. It will tell first packet is received. To send a second packet, second part, so the second one is received at here. You send a third, second is received, first is received, third is not received. Okay, you send a fourth is received. So which one is missing? Third one is missing. So you can able to think, understand third one is only missing, you'll send only third. You don't need to send entire data again. Only which part is missed, that part only you will send. That part only you will send. So to make much easier, so to reduce the time to send corrected data. Okay, you need to send entire data again and again because you already chopped the data. So you're sending piece by piece. So faster you can able to send, more accurately you can able to send. If any packet is missed, no problem. The missed packet only, missed part of data only you can able to send. So that is use of segmenting and numbering. One more important is, guys, I send like this. First one is received, good. Second one is received, good. Third one is not received. I received fourth one. Then I received third one. Pattern is changed, right? So I have to send hello, how are you? So now it is send hello, how you are. Okay. So that pattern is changed. No problem because the numbering and sequencing are done. So automatically will order correctly. Once it is received, all packets, it order the packets into a sequence matter. So that's why it is called a error correction. At transport layer, error correction will happen. What is meant by error correction? You send a segmented data to the destination. Destination assembles all the segments together and using the sequencing and numbering, so it will order the data into properly. If any data is missed, automatically the source will send that missed data again. It will be order entire data into correct path. So it will understand the exact complete data it will receive. Then it is say okay. Okay. So that's mind is not working proper. Okay, so understand transport layer, segmenting and numbering, and error correction. Hmm? Numbering and sequencing, segmenting data. What is segmenting? Data is chopped into multiple small parts. Okay, multiple segments. That is called segmenting. Numbering and sequence. The data is, they put a number for a sequencing purpose. So at receiving side, once all the segments received, all the segmented data is received, they put it in a sequence order. Means it will, the system will put it in a sequence order. Okay. When no one is responding. Guys, please respond.
Sir? Yes, sir.
Yeah.
Yes, sir.
Okay, good. So transport layer also doing this multiplexing and demultiplexing of TCP and UDP part. Okay, guys, what is this TCP? Transmission Control Protocol. UDP, User Datagram Protocol. Transmission Control Protocol. What is the Transmission Control Protocol? You can see like this. So this is type of protocol. So we have discussed different types of protocols like HTTP, HTTPS, FTP, SMTP, POP3, IMAP. Okay. DHCP, DNS. We discuss different types of protocols. Okay, so the protocols can be TCP type or UDP type. Again, we discuss the protocols like a HTTP protocol, FTP protocol. Okay, we discussed about a Telnet or SSH protocol, right? So we discussed some protocols. So those protocols either TCP type or UDP type. These are example of TCP type protocol. UDP type protocol is TFTP, DHCP, DNS, UDP type protocols. Some protocols, both behavior is there, TCP and UDP. For example, DNS, TCP as well as UDP. Okay, for supporting all I have written here, but exactly TFTP is UDP protocol and TFTP is a TCP type protocol. Means a protocol can be TCP type or protocol can be UDP type, or it can be both. Possibilities also there. Okay, it can be both. It depends upon sending and receiving type of behavior is there. So what is a TCP type protocol and UDP type protocol? I'm telling very simple pattern. So originally the synchronization something so much of story is there. So that much not required. Only for our understanding, guys. This is source. This is destination. From source to destination will send, right? So source to destination. I send a packet to the destination. In TCP type protocols, means if you are using FTP, HTTP, Telnet, SSH, RDP, SMTP, okay, so that protocol's behavior is like this. You send a packet to destination. So once destination is received, destination will give an acknowledgement. It will give an acknowledgement that indicates it received the packet. Okay, nowadays we are all online applications only. In my time, so that time when we do any application like a gate application, MSET application, okay, when you put an application, we put an acknowledgement card. You put a acknowledgement card. In that acknowledgement card also you have to write your name, address, kind of stuff. Whenever that side they received the packet, whenever they received an application, they resend the acknowledgement. They'll send back the acknowledgement. Okay, so the acknowledgement is a proof that is they received. Even we do registration post that time. So registration post, like I want to send a document to my office. So what I have to do? So I put a document in a cover plus an acknowledgement card. When the organization received my document, whenever they received my application, what they will do, they resend back that acknowledgement means they received a packet successfully. It means it shows the guarantee that packet is delivered. The same way it is, the source send a packet to destination, destination received, and the destination will send back an acknowledgement to the source. That means the packet is delivered. Same way, you are sending a packet and packet is received at destination, destination send an acknowledgement. It means packet is delivered. For example, you send a packet, the packet is not received. So it won't send any acknowledgement. It won't send any acknowledgement. Meaning is destination is not received a packet. Okay, you send a packet, destination is received, but it's sending an acknowledgement, but you didn't receive the acknowledgement, for example. That means you think packet is not received. Either it is, if you don't receive an acknowledgement, means the destination is not received a packet. So what server will source will do? Source will resend that packet again. So source understand this particular packet is not received by destination. So it will resend that packet again. So how source understand destination is received a packet, destination send an acknowledgement to the source. If source if source not received any acknowledgement from the destination, meaning is source, meaning is destination not received a packet. Source and destination in UDP. Here it is simple. In UDP type protocol, for example, you are using TFTP protocol. You send a packet, destination is received or not received. You don't know why, because it's not sending any kind of acknowledgement. So destination is received or not received. You don't know whether it is received or not. You just send packet, but you don't know packet is received or not. Okay, so when final packet data error occurs, you have to send it again. Okay, so there is a things, and this is a usage of different protocols. TCP type protocols will do based on the acknowledgement. Send a packet, destination receive, destination given acknowledgement. Okay, that is called reliability. Reliability means packet is received, source knows, destination received a packet. What is UDP type? Source does not know, destination is received a packet. Okay, it's not some separate thing, guys. UDP type protocols, TCP type protocols are there. Understand this part? TCP, UDP, acknowledgement, no acknowledgement.
Sir, once repeat TCP and UDP, sir.
What it is?
TCP and UDP protocols. Once repeat that, sir.
Okay. We have seen different protocols, right? Okay. Not
Sir.
only this, how many protocols are there? So these protocols, either TCP type or UDP type. Either TCP type protocol or UDP type protocols. If it is show some list, I can show you that. Yes, see, this is a protocol, and either it is TCP type protocol or UDP type protocol. Sometimes some protocols, both TCP type as well as UDP, depends upon the way place it is behaves. Okay, so it is TCP protocol, TCP protocol, TCP protocol, TCP protocol. Okay, these are either TCP type or UDP type protocol. Okay. Next, if it is a TCP type protocol, for example, FTP is a TCP type protocol. Okay, the behavior is like this. When it is communicating, I'm sending a packet. At other side, they received a packet and they will give an acknowledgement. That is, meaning is it is received. Simple, guys, to understand. You got the blue check marks. What is this check mark represents? What is blue check mark represent?
Message read. Everybody have.
Message is read by the person, right? Receiver. I understand he opened the message. He see the message. This means he received a message, not seen. Okay. So only one point we'll see. One is like a delivery message. So I received an acknowledgement from the destination means destination received my packet. Okay. Like a delivery message that used by TCP type protocols. Okay. TCP type protocols. UDP type protocols will do like this. It is, they will send it. This checkmark feature is not there earlier in the WhatsApp. We do not have a checkmark feature. So you send a message, other person received or not, we don't know. So only if he responded, and then we know he received a packet. Okay, he received a message, right? Same way it is like that. So you send a packet to the destination. Destination won't give you any acknowledgement. Just you have to send it. That's it. That is a behavior of this UDP type protocols. Now got it?
Yes, sir.
Reliable, non-reliable protocols. What is reliability? Source knows destination is received a packet based on the acknowledgement it receives. Non-reliable, source do not know the destination is received a packet or not. Okay, that is reliable, non-reliable. Connection oriented, connectionless. Lot of people will do mistake understanding connection oriented and connectionless. Guys, here's a connection oriented means it's a two-way of response is there. One is sending, another one is receiving. Acknowledging. For example, I asked, do you understand difference between TCP and UDP? You responded yes or no kind of stuff. So it is connection oriented. I asked a question, do you understand IP addresses? And you didn't give any response. It is connectionless. Simple to understand. Okay. No acknowledgement. Acknowledgement based protocols, TCP type protocols are acknowledgement based. UDP protocols are no acknowledgement based. Source knows destination is received a packet. Source does not know destination is received a packet or not. Okay. Some protocols are TCP type, some are UDP type, some are having both things. Reliable, TCP, UDP, non-reliable. Connection oriented, connectionless. Connection oriented means because of all these features. But it's acknowledgement based, it is reliable. Source knows the destination is received. Destination is telling I received a packet. That's why it is called connection oriented. Connectionless means destination is not telling you anything, they received a packet or not. Okay, it is not belongs to wired or wireless. So why I'm trusting that one? Because some places people are telling connection oriented means wired type of network. Connectionless means wireless network. No, it is wrong. Okay, connection oriented means, so guys, I connected to Wi-Fi. I connected to Wi-Fi. I use protocol HTTP protocol. Or maybe I'm sending a mail, receiving a mail. SMTP protocol I'm using to send a mail. I use SSH protocol to connect. These are all TCP type protocols only. Even it works in Wi-Fi network. Why? Because of the method is connection oriented, meaning is destination will give an acknowledgement that is I received a packet. That's why it is connection oriented, not because of wired or wireless. Connectionless protocol. Why it is connectionless protocol? Okay, for example, I'm connecting my remote router, or maybe I'm trying to deploy some configuration in my remote server. So using TFTP protocol. Either it is wired or wireless connectivity I am using, it's a connectionless because it is UDP type. Means only sending and receiving or not, we don't know. Receiving side, it is received or not, we don't know. So that is a UDP type and TCP type protocols. And our transport layer also do the flow control. What is the flow control or windowing? Okay, flow control or a windowing kind of stuff. Guys, I am using a high speed data connectivity, 1 Gbps or 100 Mbps or 10 Mbps type of connectivities, right? Other side may not use that type of high speed connectivity. So I'm sending, other side is receiving. So I will estimate how much at current port capacity, current traffic. So I will estimate how many packets I can deliver at a time. The windowing or flow control is almost all same concept, only small differences are there. But concept of flow control or windowing is, okay, I'm sending a message. For example, I know better English, I can speak very fastly. But your capacity of hearing English is very slow. And maybe I have a very good knowledge on a particular topic. I can finish up 5 minutes, 10 minutes, I can go read and go for it. Okay. So what happened? You are not having that capacity. So miscommunication will happen. So some part of information you may not able to hear, right? You may not able to understand. You are may not able to hear first of all. Okay, you may hear first line, second line, third line, you missed, fourth line missed, fifth line you got it. So what happened? Some data can be possible that is dropped. You miss it. The destination miss possibility of certain data. Okay. So what is windowing and or a flow control will do it? It will estimate how much the destination can receive at this particular time. At this particular time, because destination is also busy with the network port, right? So it will estimate how much destination can able to receive in this particular time. Based on that only packet will send. For example, your freshers have to go very slowly. There is an experienced person is there, or maybe already learned person is there. I can go little faster. For example, I'm also told about SAI processor. So he's having a lot of experience. When we discuss so many things with the connection, without connection kind of stuff. Okay. The level is a little different. So he speak, he don't teach me, or we don't discuss in a pattern like as a fresher. We discuss with a high level. Okay, so it's not like different capacities, right? So same way, there is a server with a fiber optical cable connection. Their storage is a fiber optical. So high speed, there is a 25 Gbps data transmission capacity is there in both the sides. That much packets they will send it because both side capacity is good. So both can able to share, transmit the data. But my laptop is 100 Mbps connection. So it will able to transmit data under 100 Mbps. Okay. Yeah, so that's enough. Okay, flow control and windowing. It is estimate. Source estimates. Source estimate destination receiving packet capacity at a time. It is there. Okay. What is PDU? Packet data unit. What is PDU? Packet data unit. Data in layer is called a PDU. So we discussed about a application layer, presentation layer, session layer. So what are the data in the what are the data and what are the format of data it is? We call it as a PDU only. And PDU here is they say data only because nothing is added to this data. Only format maybe changes. Nothing will be added here. So data in the layer called a PDU. This is transport layer. Transport layer data is called PDU. So this PDU, again, this is a PDU. Okay, it will be added with a TCP header. Okay, what is a packet data unit? So each layer data is changing. So first layer is actual request, actual information is there in first layer. In the second layer, data is compressed encrypted, encoded data is there. Session layer is still combined all the data into one single session. It combines all the data into single session and create a session ID on it. Okay, so each layer data is there. That data we call it as a packet data unit. Okay, in TCP, in a transport layer, TCP header is added to our PDU, means our data in the layer, it will be added. The total one we call it as segment. Guys, the data in the transport layer PDU is called as segment. Okay, so the packet data we call it as transport layer, the data we call it as a segment, the PDU we call it as a segment. TCP header is added to your PDU. What is this TCP header? It contains information about your segmenting, means size of each segment, segment information, numbering and sequence information, protocols, multiplexing of the protocols, what we are using here, that will be in the TCP header. That added to your PDU, and now it is become a segment. This segment is sent to the network layer. This segment is sent to the network layer. Guys, understand transport layer? Only 3 more layers are there. So do you understand transport layer?
Yes, sir.
Transport layer's PD is called a segment. Very good. The segment is sent to the network layer. What is the network layer will do with this your segment? It take the segment, add some information. What information? Routed protocols and routing protocols. What is routed protocols? Logical addressing, like IP addresses, IPv4 or IPv6 addressing is called a routed protocols. Routing protocols will tell how to reach the destination. Different dynamic routing protocols are there: RIP version 2, RIP, RIPv2, IGRP, EIGRP, OSPF. Okay, these are the different routing protocols. What is the help of this routing protocol? Using these routing protocols, we can able to reach the destination. My laptop is here. I can open google.com, facebook.com, youtube.com. They are located in a different geographical locations, but still I can able to reach them. How? Because of in between there is a lot of routers with the routing information. So using routing information, I know how to reach the destination. Okay. So network layer contains routed protocols and routing protocols. So that information is added to your segment, means what is your IP address, what is the destination IP address, what is the your IP source IP address and destination IP address will be added, and how to reach the destination. That information is also routing information. How to reach the destination information also will be added in the network header. So that network header is added to our segment. Then total we call it as a packet. The PDU at network layer is packet. PDU at transport layer is segment. That segment we are adding a network header in a network layer, that we call it as a packet. The packet is our PDU in the network layer. Network header is equal to source IP, destination IP. Of course, routing information is also will be added there. The packet sent to the data link layer, means where your IP addresses are adding at network layer only. Data link layer. What is the data link layer? Data link layer contains actually 2 parts of layer. Like data link layer, 2 sub layers are there. One is LLC, another one is MAC layer. LLC, logical link control. LLC, logical link control. MAC layer, media access control. Logical link control. So what is this LLC will do? Dealing with the WAN protocols. Inside your network, guys, in your LAN, you need only the basic information like IP addresses, MAC addresses, communication wise. But when you are communicating outside of your network, means in the public network you are connecting. So compulsory, you have to connect with the WAN protocols. Outside of network, WAN protocols we are using like PPP, HDLC, frame relay, MPLS. These are the different WAN protocols are there, even including PPP, OE, point to point or Ethernet protocol also comes under WAN protocol. Okay, so data link layer maintain WAN type of connectivity, WAN type of protocols are in at a layer 2 data link layer. That layer is LLC. Another is a MAC layer, media access control. You know what is MAC address? Every NIC has a MAC address. You are connecting your device to the network, either wired device or wirelessly. So we are connecting to the network either through wired type of connectivity, wireless connectivity. Whatsoever it is, that adapter having a MAC address. Okay, either it may be internally or externally, whatever it is, it has a MAC address. So that MAC address is actually controlled here at a 48-bit MAC address it is and represented in 12 hexadecimal. Guys, we received a packet from the network layer. Okay, we received a packet from the network layer that for that packet, two things will be added. One is data header and data tail. Source MAC address, destination MAC address will be added to your packet, and there is a CRC will be added to your packet only. So again, source MAC address, destination MAC address, and packet and CRC. This combinedly we call it as a frame. What is CRC? Cyclic redundancy check. This is a CRC is an algorithm. It create a number, a small CRC check number from your data only. What is the use of the CRC algorithm? It verifies your data for errors. Is your data is good or corrupted at destination? You send the data at destination, data is received, and this CRC algorithm verifies your data is good or corrupted. So data link layer, at data link layer, what happens? Error checking. Error correction is occurs at transport layer. Error checking occurs at data link layer. Okay. So your MAC address, source MAC address, destination MAC address, your package, and CRC. That is a frame. This frame is sent to the physical layer. What is the use of CRC? For error checking. Where error checking happens? At layer 2. Guys, understand up to here? Transport
Yes, sir.
layer. Yeah. And network layer, data link layer. Last one is physical layer. The frame is converted into bit stream. Physical layer, the frame is converted into bit stream. The bit stream means it's like a 0101 type of bit stream only. Depends upon the way your physical connectivity is there. So physical connectivity can be using a wide type like a coaxial type or a UTP, STP type of connectivity. Or you can use a Wi-Fi kind of stuff connectivity, or maybe you use a fiber optical type of connectivity, right? Depends upon your connectivity data again converted into that related signal. For example, use UTP STP connectivity. It is a copper wire, so it need electrical kind of stuff, right? So it become an electrical signal. You connected to Wi-Fi, so you are transmitting data. Your connectivity is so wireless type of connectivity. So data your bit stream is converted into radio waves with a different frequency signals. Fiber channels. So data is the bit stream data is converted into light waves. So physical layer is all about the physical connectivities, either wired, wireless, either using UDP, STP or fiber optical cables. Okay. And data link layer is mainly about a MAC address. Okay. MAC address. Layer 2 data link layer is about a MAC address. Okay. LAN based connectivities, of course, WAN based connectivities. Network layer is all about logical addressing and routing. And the transport layer is all about how to segment the data, how to numbering and sequencing, how to multiplex these UDP type and TCP type protocols in the data transmission, flow control of your data. Sequence session layer is all about the creation of session, assembling the data in with the session, okay, maintain the session, terminate the session. Presentation layer is all about how to encode the data, decode the data, compress, decompress, and encryption and decryption. Application layer is all about what application you are using to communicate in the network, what type of communication you are doing, and what kind of application using for that communication. Okay, so these are the 7 layers of OSI model. Okay. Let's understand this part up to here.
Yes, sir.
Okay. Yeah, this is source, this is destination. From source, it starts here. From destination, bottom to top. So source from source, top to bottom, and destination top, bottom to top.
Time.
Okay, 2 minutes. Application, presentation, session, transport, network, data link, and physical layer. Here, physical layer, data link layer, network layer, transport, session, presentation, and application. Simple. Here it is. Presentation do encoding. Here it is decoding. Encryption, decryption. Compression, decompression. Session will be created. Session will be taken and understand and maintained from here. So it segment the data. It assemble the data here. A transport layer, data will be segmented, means chopped into small parts. Those will be assembled at destination transport layer. Network, so you're sending a source IP, destination IP with your PDU. So that is your packet. Okay. So again, it will inspect your source IP, destination IP, verify the source IP, means APC IP address, VPC. And segment. Okay. Data link layer is all about a source MAC address, destination MAC address, CRC. So here in the destination, what happened? It uses CRC to verify your data. So make sure data is good. So then also it will check the source MAC address, destination MAC address. So physical layer, again, you convert bit stream to electrical signal, for example, and it here electrical signal is again converted to bit stream to frame. Okay. Frame is again packet to segment, like that it will happens, means top to bottom, bottom to top. Guys, understand OSI model? Actually, I thought I will get more time on the OSI model, so we didn't get it. So last part here I will tell and we'll close for today. That is a comparison of OSI model and TCP IP model. That will finish off this particular part topic. Tomorrow we'll start different. Yeah, I will tell separately the troubleshooting part. Okay. Guys, we are currently using TCP IP model only. This protocol suite only we are using. If you are comparing with the OSI model, application layer, presentation layer, session layer. So these 3 layers duty done it with the single layer of at TCP. TCP layer, TCP IP having only 4 layers: application layer, transport layer, internet layer, network access layer. Only 4 layers. But in OSI, 7 layers are there. It meaning is here network layer duty means network layer is a combination of physical and data link layer. Internet layer is network layer. Transport layer is transport only. But here it is application layer is a combination of application, presentation, session. In TCP/IP, application layer is nothing but a combination of application, presentation, and session. In TCP/IP, transport is same as a transport duty of OSI model. Internet layer is network layer in a OSI. Network access layer is a combination of data link and physical layer. You know what is our NIC? NIC or LAN card. Under TCP/IP, it comes under network access layer. Okay, so this is the comparison of OSI model and TCP/IP model. Here I try to explain ARP protocol, but it's okay. I'm giving some network related commands that I will explain from here. Troubleshooting or maybe separate level tell these things. Okay. Up to here, understand guys? Clear? OSI model. Okay. Do you understand up to here? Entire our OSI model, 7 layer and each layer work.
Yes, sir.
Very good. Okay. I can do 1 minute. Okay. Yeah, that's it, guys, for today. So